Problem 23, find the limit. So always try direct substitution and see what happens. Sometimes you just get the answer. Sometimes you get something else that's very revealing. So in this example, we're going to put in the -5, like it says there. And so -5 squared plus 5 times -5. That's the numerator. See what that gets. And on the bottom, we have -5 squared minus 2 times -5 minus 35. Okay, so what does that get us? So on the top, we get -25 there and 25, so you get 0 on the top. And on the bottom, we get -25, take away 10 more, -35. Excuse me, we get 25 plus 10 minus 35, you get 0. So in other words, this is basically 0 over 0, which means that if we were to graph this rational function, we'd have a hole. And so you can't really find the limit very easily with direct substitution by putting it in. When you get 0 over 0, you get the hole. You're trying to plug into the hole. So the better way to go about this, one of the techniques, is to try to factor. So that's what we're going to do next. We're going to factor the top and factor the bottom. Okay, so factoring the top, we're going to find the limit as x approaches -5 still, but first we're going to factor the top by dividing out an x from both terms. So we get on the top, and on the bottom, we're going to factor out the bottom. We're going to get x, we're going to get x. Now we know there's a hole here, so I know that the factor is going to be x plus 5 on the bottom and the top, because it looks like that's how this is going to factor. So I got a plus 5 here, and a -7, I believe. That's the type of factoring where you FOIL it back up and see what works. That will work. So like I said, it has an x plus 5 and an x plus 5. That's where the hole is located when you have a common factor. So I'm going to cancel that out. And now I've eliminated the hole. And then now I can directly substitute into what's left over and get my answer. And so your answer will be, let's see here, -5 on the top, and then -5 take away 7. So that's -5 over -12, which is 5/12. And that should be our limit. Okay, so 24 is a similar question. All right, so yeah, this is going to be just like the last one. Always try direct substitution when doing limits. And I'm going to save you the time, but I think when you plug this in, you're going to get something similar like the last problem. Yeah. So if you plug the -3 into the top, you get -3 squared plus 5 times -3 plus 6. And do it on the bottom. 2 times -3 minus 3. Anyway, you get 0 over 0. That's an indication that where you're trying to find the limit, as x approaches -3 right here, you're trying to find the limit at a hole, which means there are some ways to identify that hole and bring out and get rid of that hole. And the technique we did in the last problem was to factor, so we should try to factor that right now. So let's get... Okay, so the limit so we're going to factor the top and the bottom. And because we know there's a hole, there should be common factors. So if you do this, I think you get, what do you get? Plus 2 plus 3. So we either have to have an x plus 2 or an x plus 3 on the bottom. So I'm pretty confident of that. And let's see what it ends up being. Let's see here. Plus 3 and a minus 1 are our factors, I believe, right? So that works. And so just as predicted, we have x plus 3 and x plus 3. Cancel out your common factors. Essentially, you've eliminated the hole. And now we can directly substitute the -3 into what's remaining and get our answer, which is -3 plus 2 and -3 minus 1. That's -1 over -4, which is 1/4. And that is our limit.